That is Twitter taken care of. Let's also tell Discord. Boom. And Telegram. Key. Like this. Okay, let me pull up on the secondary monitor as well, so that I have chat. Okay. Day 23. Just 3 more days to go for Advent of Goat, today, tomorrow and the day after, which will only be one part, because the last day is always just one part, and then you can do something when you have all 49 stars to get the 50th. Yeah, so let's start reading it. I must, a small disclaimer, I'm not feeling too well, so I'll just see how it goes. If I start to feel not well, I'll probably stop and do this tomorrow, but yeah, I think it's something I ate. I'm not sure, but I'm not feeling too good right now. But yeah, let's just see how it goes, and we'll move from there. Day 23, Amphipod. A group of amphipods notice your fancy submarine and flag you down. With such an impressive shell, one amphipod says, surely you can help us with a question that has stumped our best scientists. They go on to explain that a group of timid, stubborn amphipods live in a nearby burrow. 4 types of amphipods live there: amber, bronze, copper and desert. They live in a burrow that consists of a hallway and 4 side rooms. The side rooms are initially full of amphipods and the hallway is initially empty. They give you a diagram of the situation, your puzzle input, including locations of each amphipod, A, B, C or D, each of which is occupying an otherwise open space. Walls, hash and open space dot. For example, okay, the amphipods would like a method to organize every amphipod into side rooms, so that each side room contains 1 type of amphipod, and the types are sorted A to D, going left to right, like this. Amphipods can move up, down, left or right, so long as they are moving into an unoccupied open space. Each type of amphipod requires a different amount of energy to move 1 step. Amber amphipods require 1 energy per step, bronze require 10, copper require 100 and desert ones require 1000. Amphipods would like you to find a way to organize the amphipod that's required the least total energy. However, because they are timid and stubborn, the amphipods have some extra rules. Let's see. Amphipods will never stop on the space immediately outside any room. They can move into that space so long as they immediately continue moving. Specifically, this refers to the 4 open spaces in the hallway that are directly above an amphipod starting position. Amphipods will never move from the hallway into a room unless that room is their destination room and that room contains no amphipods which do not also have that room as their own destination. Okay, if any amphipod starting room is not its destination room, it can stay in that room until it leaves the room. Okay, for example, the amber amphipod will not move from the hallway into the right 3 rooms and will only move to the leftmost room if that room is empty, or if it only contains another amber amphipod. Okay, so once an amphipod stops moving in the hallway, it will stay in that spot until it can move in the room. That is, once any amphipod starts moving, any other amphipod currently in the hallway are locked in place and will not move again until they can move fully into a room. In the above example, the amphipods can be organized using a minimum of 12,521 energy. One way to do this is below. Starting configuration. So be up and to the right. Oh no, this one, up and to the left. Let's see. Taking 4 steps and using 40 energy. The only copper amphipod not in its side room moves there, taking 4 steps and using 400 energy. The desert amphipod moves out of the way, taking 3 steps and using 3000 energy. Then the bronze amphipod takes its place, taking 3 steps, okay. Okay, so this is simultaneously. This one, no wait, where is the D coming from? Oh, there. So this one moves here and then that one goes in there. Left one moves there. Okay, they have to leave that one out. And then that one goes back, okay. Whew. What's the least energy required to organize the amphipods? Okay. So this is like a interesting challenge. I mean, there's probably a way to just brute force this, but I'm thinking, is there a way to be smart about the logic? Because this one is in the right space, it should never have to move because it's the lowest one in. This one is in the right place. This one needs to go here. This one needs to go here. This one needs to go here. This one needs to go there. So I'm thinking you probably need to do all the moves that you want to do and then do them in reverse or something. So let's take this one for example. So you have B, A, C, B, C, A. Hey Simon, how are you doing? C, B, D. So in this case, the lower A is in its right spot, and the C is in the right spot. So then you want, for this case, you want like D2, D4 needs A4 to move first. So this feels like a constraint solver. Because you want to get like A4 wants to go to A1, but for that to happen you need to move D4 out of the way. Since it needs to go to D as well, it can just move to up plus right. Frustrated. This is a tough one, I think. Did you not manage to do today's one? I'm just thinking about what what other constraints that I can program? Is there anything that I can... Because also in this case you want to limit the energy used. And the thing is, like, if I would do this from my head, I would like, okay, move C all the way here, move D all the way here, move those B's in here, then move the C in there, put the D to this spot, then move the A there, and then move both D's in there. But that's actually more expensive than the reasoning they had. So I'm like, I'm still thinking, like, even how would you brute force this? Because you have to do some kind of like dependency tree or something that you walk. Because I can figure out a way to do this in my mind, and then I still have to optimize it for energy. Just trying to figure out how to even code it. So what I could do is, like, these two are in target. The rest of them, are not. So I could just start from there and have all of these as possible first to bring home, right? And then just figure out in which ways we can pull them out. So, like, okay, then I have a branch where it focuses on A, and a branch where it focuses on this one, this one, this one, this one, and this one. And I wonder if that's even possible to brute force like that, because there are quite a few options after each one of them. And you can only move them once. So I wonder if I start coding it like that, if they find it probably can find a solution, and after it finds the first solution, you can have like your maximum value for when you want to abort. But this also feels a bit like that pathfinding algorithm, like the Dijkstra thing. And the Dijkstra thing is actually built with the priority queue to make sure that you do the least expensive route. So it feels like a variation of that, maybe. But it's like an estafette. There's so many conditions in between, and I don't know how to code that. Also, you probably weren't here when I said that I'm not feeling too well today, so I'm not sure if I'll how long I'll stream. And reading it now and not getting a good idea, I should probably just go to bed. But yeah. Let me look at the input first, see how many steps there are. Oh wow, it's still only that. well, it's still 4 parts. So, but it's not that bad. So I wonder if I can write code that builds a strategy to even get everything in the right position. Because in this one, none of them are in the right position. So how would I code that? Because they can only move into, like if I move the D out of the way here, this B can go here temporarily if I wanted to. Not that that's a smart idea. Maybe you could put the D here and then put that A here. No, that's not great. So I can move the A here and then move that D here. That would let you move the C's in here, then B back in there. Then you can put the A next to this one, the D in there, the other D in there, and then the A's back like that. But how do I code that in a way that we can solve this? Let's start with the test input. Let's see if we can do something about this. So far I don't feel great about this, but would have been nice if I had like an idea already, but yeah. This is a new kind of problem for me that I have not tackled before, so it's we'll have to see. Const string test input. Good question. Yeah. I wonder if I'll even parse it like this, but I wonder what's more useful here. If I just code up this room, or that I find a way to parse it and use that. Because if part 2 does like, okay, now repeat this room 50 times or something, then I'm effed if I don't write something for that. But that's assuming I even get to part 2, right? Let's just let's see, public list int hallway is new blah. actually this can just be an array because, well, it's fixed in size anyway. It doesn't grow, doesn't shrink, it's fine. Public stack char room A, room B, room C, room D. Let's see, 0, 1, 2. Okay. And this will be, let's see, what did I say? 0, 1, 2. Okay. Four, 6, 8. Okay. So let's do room A dot room dot push A B D and then C. This one has C and then B. And this one has A and then D. Okay. Okay, so that's the problem set. Okay, let's see. Dictionary car int target room. Okay, so we have A 0. B, this needs to be accolades. Come on. D, come on, D. Boom, boom, boom. Okay, so now we have our rooms, we have a mapping. Do the same inverse actually. Oh, am I not allowed to do that? F that. Let's say we'll do our initializer here. Actually, it doesn't have to be a static initializer. I can just do it here. What is it complaining about? Okay, let's start this one here. Let's move this all up here. Target room, target char. This becomes this target room. Okay, here. To the dictionary. We invert that one. So we have a lookup as well. Should have done it this way in the first place. I just finished part 2. Okay. I still don't know what part 2 will hold. I'm not even sure that I can finish part 1, so. So that is setting up the test. So now I need to have like, I need to know which things we need to move, and I'm thinking actually that we move the expensive ones last, because that means that they move less, but I'm not sure if that is true. We need to know where they can go, which part is blocked off. Okay, so let's just see which ones we need to do. Let's see list. Int room index. Int car to move. Int target room. I don't even know. Needs to move. Let's just start with this. So we do for int I. Can't believe this I solved by hand, but I do have a working model of the whole system. All of my automated approaches failed, some with Stack Overflows. Okay. Well, if you run into Stack Overflows, you can always rewrite it into like a loop. Like any recursion can also be written as a loop, but it's a pain when you have to rewrite your code. Let's see. For I is 0, I smaller than rooms count length plus I is rooms Hi. Oh yeah, oh, we have that one as well. Move cost. Actually, I can just do that in line here. It doesn't really matter. So we have A is 1, 10, B, C, D. If only that was the only problem I had. Yeah. I'm curious to see what part 2 holds, but the way things are going, and since I'm not feeling too well, I'm also not really at the top of my game right now, but it also is not clicking yet, so I'm just going through the motions of let's code something that I can think of and see if we can go from there, but this might just be a short stream today where I'm just gonna call my losses and just go home. But yeah, let's first see what we can do. So we have, in this case, room.room peak. I actually can do no. Yeah, that's the bad thing about having a stack there. But yeah, I can just do No, you can't. Would first give me the 0 or the last one? Just without moving it. Yeah, I wonder if I can go one deeper with Could have saved myself 10 hours, but just working it out on a piece of paper. Ouch, 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 ouch. 10 hours is a long time. That is a long time. Actually, does it even matter here? Yeah, because you need to plan that move. That's okay. Not the most optimal, but yeah. For each chars. Boom, 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 boom. Let's see, target room. Dun, 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 dun. Actually, this is also not true, because if the one after it let's see. I can actually do this, which is funny. Just item 2. Let's see here. Needs to move. And then we add, let's see, I, comma, C, and it's actually 2 of them. I think it also needs like the index. This also makes me wonder, is C actually, let's see, control, let's see, I wanted to try and solve it properly. Yeah, I can imagine. But that's also the way I like to do stuff. Boom, boom, boom. And I still need to figure out which one of this is the first or the last here. So let's just do it for now, like this. I probably need to make sure that I run day 23. I actually did that, okay. What's the problem? Ah, yeah. I'm just an idiot here. So this be 0, 1, 2, 3. You can see I'm very sharp today. Let's see. So we have target room. Wait, what? Oh yeah, alright, so BA, and which one is the index here? BA, so the top one will be first. Okay, so item 1 is the top one. Okay, so we need to check item 2, and if that isn't the right one, so let's copy this. If 2 isn't the correct one, we need to move both. Bottom 1 isn't correct, need to move both. I'm really pleased I got part 2 first try. I spent a lot of time modeling what I needed to do. Probably would have given up if I got it wrong. Yeah, I know that feeling, man. So kudos for solving it. Yeah, so top one will be index 1 for me, and then the bottom one, index 0, and the bottom one will be index 1. For now, that's fine. Has the final piece already in position? Okay. So let's see, if I run this, it should give me back those two that were in the right position, right? Yeah, room 0 has the final piece and room 2. So that's what I wrote out here as well. Right, 0 and 2. They have the final pieces in position, and the rest of all the things I have in a move list. I'm just wondering if I can brute force it now to have like all the possible moves. Something in my head says you need to take care of the outer ones first, but that's difficult. How did I solve it? Is there a clue in there? So they tried to solve the middle first. Maybe it's just like, okay, can we complete a hallway? But is that the most efficient? I'm just trying to figure out what the way would be to do this. Because I think there needs to be like
There's always two parts, right? You need to get to your destination, and there might need to be stuff removed to get there. So what do they do here? They first take care of C. And then try to do B. So they do the middle ones first. So wondering about this, like the starting stage. So they could do C go to here, then D there, D there, no D here, then A out, then move the D back in, but then you have done an additional move for C. So I think the reasoning becomes, once you figure out that you have to do, hey Luke, welcome. I'm not feeling too great today, so I'm not sure that this will be a long stream. But I was just trying to reason how this works. So what we figured out, if we try to do that, let's say we target D, we have to do an extra move for C and an extra move for A. And the A might be avoidable, though we could move that D here and then move the A here. That would back up that one. Let's see. Okay, you could do B here, C there. No, that would also be an extra move. I'm having a hard time figuring out the moves with in my head. I still don't even know how to code all of them. And I don't know what the search space will be if I just random move everything. So I started out by writing out all of this, so it gives me all of the things that are in position and all of the moves that you might want to make, right? So here we have a list of all the 6 characters that need to move. So then you could try to pick all of them by one. Like try just starting out with one of them and see how you can get it to the position. Let's see if I can even code one of them. For each var to do in needs to move. To do dot room index to move. Right. If to do dot index is 0 or rooms to do dot room index dot room dot count is 1, else other part needs to move first, right? index because then we do rooms room index to do dot room index dot room dot peak. We need to move from room blah to room and this will be room dot to move room mapping target room to do dot to move. Okay, let's write this out. That should give us some more. Okay, we need to move B from room 0 to room 1, C from room 1 to room 2. Can't move D because C needs to move out of the way first. We need to move B, blah blah blah. Okay, so this is the analysis of what we need to do. B out of 1, C out of 1, can't remove D out of 1 because C needs to go first, B out of 2, D out of 3, can't remove A from room 3 because D needs to move out of the way first. Okay, so yeah, we're getting there step by step. I'm just not sure that we're closing to our solution yet. So we have our candidate of 4 moves. We could still say that we can do these moves just by pushing out our blocker. Next we need to know if there is actually something blocking our route. Let's see. So let's do a function bool can move. Int from int 2. Boom, 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 boom. What am I doing? Okay, I just need to close that one. So there we have hallway. Hallway dot sum. No. For int I is from I smaller equal 2. Let's see, if 2 smaller than from. Let's see if hallway I I should probably initialize that with some value. Why is there? Why is this an int? Let's call this a char. New string. Actually, I can do. Array block. Okay. I could probably just count this once and have it in there, but 11? Is that correct? So it's 8 plus 2 plus 2. Wait. 2, 4, 6, 7 plus 4 is 11. Yeah. Okay, we can just say new string 11. Okay. So now we need to do. Okay. If can move to do the room index. So we do int target room index is that. And let's just put that here so that we can use it. Okay. We can't move because there is obstruction. Okay. I mean, that should never happen, but okay. So let's say if I do hallway 5 is a three to 3. Wait, what? We need to move D out of room D. That's interesting. Because that one isn't correct. Oh, yeah. It is correct. We need to move it out because there is an A in the way. Strange that there's never an obstruction, because there should be one, I think. Oh yeah, because I need to get the hallway mapping. Let's see. Hallway exit there, yeah, okay. So it should be like that. Can't move C because there's obstruction. Yeah, okay, cool. Okay, so that also works. Still not sure
what to do next.
But we have logic there in place now to let me see. I still wonder how to implement the solver for this. Because if I just take something and move it out, it could be an option, right? It's like, okay, we go from, like, let's say the first move is to do this. I just saw a message from Ivan on Telegram about writing an AI to play a game, so maybe I should ask him how to solve this.
Actually, let's just do that. Let's do that. Copy. Speaking of programming contests. I need to do some root finding, and I don't know what my next move is. I'll notice it after the stream. Oh. So yeah, this is my game room where we do like daily challenges for games, and everybody that beats me gets an NFT, and the top player gets an NFT. Ivan got a really nice score here, so that's nice. So yeah,
Ivan is actually somebody that creates programming challenges like this. So yeah.
Yeah, I think I'll just stop it here, because I don't really know where to move from here, because I can figure out like the options, and I think like next thing to do would be to code like, okay, I want to move this B, I know which, for example, yeah, let's say we target this B to go to its final destination. So then I can code, okay, the B needs to get out of the way of these, so that means that it can go here, or here, or here, or here. Game writing is not my thing, hence why I struggle with problems like this, yeah. I mean, this is a certain type of problem that if you know how to solve it, I'm sure there are lots of people that can just write it out without having to think much about it. It's just, if you have not solved something like this before, it can be very tough. I remember, like, for a client, I once had to do make an algorithm to create pairings of people with the least amount of recurring. Like you have sessions together. Let's see. Isn't this a lot like the maze solving? Yeah, everything is somewhat similar. Like I started the stream saying that, for like, yeah, with all the fuel costs, this feels like a Dijkstra problem, but I don't know how to code up all the subpath moves here.
So that's a bit of the issue. I don't know how to codify this in a way that I can solve it. So what I said is like, okay, what I can do is I figured out all the things that need to do. That's not the issue, and I could just branch out for each of the characters. So there are 6 moves here that we need to do. In the other one there are 8. So you can just start a branch and try to process that one. So let's say you target this one as your first. This needs to go here. So then you have 2 characters that need to move out of the way. So then you need to decide, okay, to get the bee in here, I need to wait for these 2 to leave. So these 2 need to go either over me or that way, so I can move. So either I move out and move them backwards over me, or I do nothing, have them go here or there, and then move myself. So these are all options. But then you also have, where do I go? Because there's fuel costs involved, and how does it impact the further life cycle, right? So I can put the B here, and then put the C here and the D here, and then move the B in there, and that's one variation. But I can also say, no, I need to put the B here and do the same. Or no, I need to put the B here and do the same. Or I need to put the B here and then move the C to here and then the D to here. But then it dies out and at a dead end. So then you have a variation where you put the C here and the D here. Or one where you put the C here and the D here. And then you have a variation where you put the C here and then you... Yeah, you know, there is just so many branches there. And I don't even know if I can reason about them all. So yeah, that's what makes it really hard, sadly. See, I'm just thinking if there's a way for me to code this up, because what I can do is with all that branching is keep like a global optimum move, because there is the move cost, right? Here, 110, 100 and 1000. So once there is a single set of moves that solved the issue, you get a score, and then you can do, well, that is now our best score, and everything that goes over that gets deleted, so that limits your search space a lot. So yeah, I have ideas, but I'm not really sure how to implement them fully. And I'm not 100% sure that even if I would do that, it would be doable that way, because it makes me go back to the problem that we had to solve with Dijkstra. I written a more naive implementation like the one that I just talked about, and that just ends up with too many branches. So it will never complete in my lifetime because there's just too many variations. And that was just walking around, right? Let's see what Ivan says. What are the rules? Maybe Jeff wants to rematch. Can't solve it at a glance either. Maybe if you think of the tricky rules, the search space is not too large. It can just be traversed entirely. Yeah. But like for all the possible moves though, there are still so many to consider. Like just a simple path of getting B to where it needs to go has so many options already, and that's just one branch for the first step of getting 6 things to go to the correct position. So I think it will easily be like a few billion or trillion options if you don't find a way to shortcut that. And yeah, there are limitations in the way that you move, that you only set one, but it's, yeah. Yeah, Simon says, I think I'll revisit this sometime in the new year. Yeah, I think it will be the same for me, but then I'll first will have done some research into actually the sort of problem that this is and get some perspective and ideas about how to code it. Because, yeah, my feeling at the start was like, okay, you're not going to finish this, but I was like, okay, let's at least put in a bit of effort to like reason about the problem set, get some basic functionality in there to at least codify it and see if something comes to you while you do that, but I don't. It's not coming to me. Which is sad, because this also can be quite a fun problem to solve once you figure out a way to do it. I mean, last year we had the puzzle piece with the rotations and the flips, etc. I spent so much time figuring that one out. And I think for me, my favorite one was yesterday's one, where I figured out how to like slice up 3D cubes in new parts. By now I've seen actually a few videos of people doing day 22. And I don't think I've actually seen somebody do the same yet. They all have like some higher math tricks to keep combining stuff and keep track of it all a few layers deep. I kind of like my approach, and I actually thought about like visualizing it in Unity. So like you start out, build the block, and then the new one comes in and you just like slice it with a laser, shift it out for a bit, do all the slices, and then and move it back together. I thought like I can see it in my head that it would be really cool, but it's like also a lot of work to code and I don't have a lot of time. So, and since I'm already not feeling too well, I think I'll just quit for today, get an early night's sleep for once, because that has been a long time as well, and revisit this some other time, because I don't think it's going to go the same way. Yeah, I know you also did it by slicing. I'm just saying, like, for all the people that I saw it solve on YouTube, I didn't see people do the thing we did. So that was funny to see. I expected more people to do it that way, actually. So yeah, I'm sorry if this isn't what you guys expected. I'll call it here and revisit this some other time, and let's see if we can solve tomorrow's problem. So I want to thank everybody for stopping by and saying hi. It's been nice seeing Simon and Luke and some other people just come back again and again. So yeah, that's been nice. So thank you for now, and let's try tomorrow. Bye bye. Ah, cool. I can't end the stream because something expired in my login info. Man, YouTube Studio is such a... So let's try to end the stream again. Bye bye.